Hello, today we are covering lesson 7.5, exponential and logarithmic equations. You guys will be able to solve these by the end of this lesson. So first of all, we are going to start by simplifying the following logs. So, like we saw before, if you have an exponent, this exponent can come down front when you have a logarithm, only when there is a logarithm. So we can rewrite this as x times log base 4 of 16. These guys are equivalent to each other. Now, we can actually simplify this even further by either using our change of base formula, where you have log 16 divided by log 4, or thinking 4 to the question mark power is equal to 16. Either way you do this, you will get the same solution, as you will notice here as I solve this. 4 to the second power equals 16, or using our change of base, log of 16 divided by log of 4 is also equal to 2, okay? So you'll notice that those are the same, pretty nifty there. So this guy is equivalent to this, which is equivalent to 2. So log base 4 of 16 is actually 2. So our simplification here is actually just 2x. Okay? So log base 4 of 16 to the x is the same as just saying 2x. Pretty crazy that those are equivalent. We'll do a similar thing here. We notice that there's an exponent, so with the logarithm out front, you can take the 8x down and have 8x times log base 5 of 1. Now, once again, you can use the change of base formula, so log of 1 divided by log of 5. I'll just change this out, is actually equal to 0. You can think of this as 5 to the what power is equal to 1? Well, anything to the 0 power is equal to 1, okay? So we have 8x times 0, because log base 5 of 1 is 0, which means our solution here is just 0, because anything times 0 is 0. Now, we're going to start to solve. One thing I want to point out is that what you do to one side, you have to do to the other. Okay? So, we have exponents that are x right now. We know if we have a logarithm, we can take that x value that's in the exponent to the front, and it wouldn't be in the exponent anymore, because we can't just take like the xth root of either side and solve there. That's not helpful for us. We still do want to get the variable by itself though. So to do that, we can say log of 4 to the x power is equal to log of 2 to the x minus 3 power. Now, these exponents, since there are logarithms with them, can now drop down in front, and we have x times log of 4 is equal to x minus 3 times log of 2. Another note over here I'm going to write, divide by the smaller logarithm. Okay? So in this case, log of 2 is smaller than log of 4, so we are going to divide both sides by a log of 2. And you can't just say, okay, 4 divided by 2 is 2. That is not correct, although when you plug this into your calculator, make sure to use the correct parentheses and everything. In this case, we do get 2 for the answer. That doesn't work for everything, though. So now we have x times 2 equals x minus 3. And we can just finish solving this. So we have 2x equals x minus 3. So x is equal to -3 as our solution. All right, part B is very similar here. We notice we have exponents that are x's. So we are going to want to use log of 9 to the 2x power equals log of 27 to the x minus 1 power. These exponents can drop down into the front. You know, I'm going to change color. So we now have 2x times log of 9 is equal to x minus 1 times log of 27. Once again, divide by the smaller log. You're left with 2x is equal to, we have to figure out what log 27 divided by log 9 is. And we get 1.5. Notice it's not 27 divided by 9. It's different. You got to use that logarithm. Oops, I missed a part. We have x minus 1 times 1.5. There we go. Now we need to distribute this to each of these guys. So we have 2x is equal to 1.5x minus 1.5. Go ahead and finish solving for x like a normal problem. And we just happen to get that this solution is also -3. When you take -1.5 divided by 0.5, you get x equal to -3. Okay? Now these next two are actually simpler, I would say. Once again, we see an x in the exponent. That means we need to use a logarithm to take it out of the exponent and solve. So I rewrote it with logarithms. This x comes down front, so we have x log of 4 equals a log of 11. Once again, divide by the smaller log. And this one you actually just have your solution right away, which if you plug log of 11 divided by log 4, you get x is about, because I'm going to round 1.7 to 1.73, we'll see. 1.73. Okay? We can do the same thing with the next one. There's just one extra step. We will have log of 7 to the 9x power is equal to log of 15. This x can drop down front based on our logarithm rules. Divide by the smaller log. That also gets us x closer to being by itself. When you solve for log of 15 divided by log of 7, we end up getting 1.39166. You can round however you want. I'll probably end up saving it. So that way I have less rounding error and just hit enter and then do divided by my answer divided by 9. That'll give me that less rounding error, and my solution for x is about, since I'm rounding anyway, 0.155. If I were to plug the x back in up there, right into this part. It'd be 7 to the 9 times x equals 15, and if x is equal to 0.155, it would check out. All right, just a few more, 3 more examples. When you already have a logarithm in an equation, you can't really solve this way either, and we don't see any exponents in either of these. So the question is, how do we remove a logarithm? Well, if you have, say in this case, 5 to the log base 5, like this, these actually cancel out. They become 1, okay? So to cancel these out, I'm going to say, okay, 5 to the log base 5 of 4x minus 7 is equal to, we got to do the same thing on the other side, 5 to the log base 5 of x plus 5. Notice, because I put a 5 on the left side, I also had to do it on the right side, and it's super helpful here because both of these cancel out, and then I'm literally just left with an equation to solve. Oh, sorry, x is not equal to 14, x is equal to 4. Got ahead of myself. Okay? Now, if there is not logs like on this one on both sides that nicely cancel out, what do? Well, you do basically the same thing. Since this is a base 4, we know our big number below has to be 4, so 4 log base 4 of 5x minus 1 is equal to, we do the same thing on the right side, 4 to the 3rd power. These guys cancel out. This side does not cancel out. You're just going to solve, and you get that, 5x minus 1 is equal to 64, because 4 cubed is 64. And then finish solving. So x is equal to 13. And lastly, we need to bring back some of our logarithm rules from the other day. And we need to start by condensing these. Bring them together. So we end up, if we see addition, multiplying the pieces that follow. So we have, since they're both log base 10, we have log of 5 times x is equal to 2. Since this is a base 10, we want to put 10 under both sides. So we now have log to the, 10 to the log base 10 of 5 times x equals 10 to the 2nd power. Log base 10 and the 10 cancel out. So you're now left with 5x equals 100 because 10 times 10 is 100. And finish solving for x, which is equal to 20. Quick reminder, if there is not a base number here, it is always 10. Okay? That is all for today. Have a great day.